Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to talk about ribs and parts to keep the structure and the long walls of your plastic parts square and true. So I got some examples here. So this is an example of a game tamer part, which is a card and domino playing rack. And you can see if you sight along this back edge here, like along here, you can see how the part is basically sunk in. And that happens because with polypropylene especially, which with a large mold shrink factor, it will basically accumulate stresses causing long spindly walls like this to like sink in as it's cooling in the mold and even after it ejects from the mold. So you wind up with basically this collapsing wall structure, and there's a little bit on the front as well. But in the middle of the part, all of this, it inherently has its own ribs, so you don't really need as many ribs going this direction to keep the part from bowing up or in and out. But bowing in this way is kind of an issue because this part does not have any ribs in it to support this wall and keep it pushed out as the plastic is solidifying when it cools off, when it is in the mold and ejects out of the mold. So to fix this problem, we added ribs to the part. So you can see these ribs on the inside here. And these ribs are kind of high aspect ratio. So they're very thin and they go in deep into the part in some areas. You can see like down there, it goes in pretty deep. So in order to machine these ribs into the mold itself, you can't really just use a small diameter end mill and come down from the I guess this side and machine in these ribs. So the best way that I put these ribs in is to actually use the sinker EDM machine, which uses electric discharge to basically eat away the metal. And to do that, you need to make a electrode. And in this case, I made a thin copper electrode that basically will just erode down to create this rib structure. And now you can see when we add ribs to support this back wall, we have a much better planarity and true to shape effect by supporting this wall when it is molded and the plastic is molten. It basically what happens is, to a certain degree, the ribs that are thin are heat sunk in the mold first, so those become rigid structures, while the outer skin, which is approximately 40% thicker than the rib itself, and I think in this case it's like the rib is half as thick, so the outer skin is twice as thick as the rib, and the outer skin is still kind of molten and still wants to shrink, but it can't really shrink as much in the mold because the thinner ribs have already set up and are solid plastic. Anyway, let's take a look at the mold and we can talk a little bit more about the sinker EDM process. So here is the mold core that has our ribs that were added with the EDM milling operation. And this down here is an example of a rib cutter that I made, and we're going to make a similar one for this particular mold, but this is off of a different mold. You can see the burn marks from the material removed. You get this dark kind of black color in the copper. But anyway, so looking at our rib cuts, as you can see, these would be pretty difficult to machine with a end mill, because it's like a less than a millimeter or less than 40 thousandths of an inch in diameter end mill would be needed. That's like 1.5 inches or like 40 millimeters deep. So that results in a very unhealthy aspect ratio and tool chatter, and it's pretty difficult to machine deep holes like this. So if we zoom in, you can see the EDM finish, and it does have a taper. I actually machined a taper into the copper electrode that made this shape, but the EDM process itself will eat away at the copper electrode, and it naturally creates its own, basically its own draft angle as well. So we're zooming way in. And I used the same tool for several ribs. You know, this one is as deep as the top one. But as I moved down, for instance, I didn't need as deep of a rib in this area. I'm trying to remember why this rib was smaller, but the same tool was just sunk in a little less deep. And why is that? I can't remember now. And then an additional tool or rib was added there as well. I think it had something to do with the gate. I'm not sure now. It's been like a year since I made these. So these are the ribs that were cut, and then finally we went back to full depth here. So I will show you how I made the electrode to cut these ribs into the core of the mold next. So we're out at the mill, and I'm using my cell phone here to try to dial in a 1 degree draft angle on this piece of copper that I superglued to a steel substrate. And here you can see I'm kind of getting a -1 degree, which should be good enough. So the intention is to shell mill with this 3-inch shell mill the 1 degree draft angle into this copper sheet. I think I only machined one side, but then I kind of worked the angle into the fixture that we're going to show next. So I did just a bunch of quick passes with this 3-inch shell mill, and didn't want to overheat the copper because the super glue you use to glue down sheet metal to a substrate, it deactivates by heating up, and that's how you basically get the super glue off. So here I'm measuring the width of our drafted angle on our copper electrode, and this is basically just to make sure we got enough exposure when we machine the profile of the rib that will then go in. So here is a pilot drill, and I drilled a pilot hole and then wound up machining a larger hole for the set screw hole in the side of the brass kind of mounting block that goes in the 3R mounting or fixture plate that connects to the 3R chuck of the EDM machine. So here I'm machining the circle out for that, basically a 5/16 bolt, and then we machine the profile of the electrode that will create the rib profile. Now the rib profile, I didn't have it go all the way across the bottom of the Game Tamer back side of the part, but rather I just kind of had the rib extend approximately 3/8 of an inch or 10 millimeters in from the inside surface of the wall. And that's so that the draft angle of the rib didn't accumulate too much and create such a thick rib. So anyway, kind of profiled and kept unnecessary rib in the middle out of the situation. Yeah, and then here I use a propane torch to heat up the copper. And again, like I mentioned, heating up the super glue that is mounting this copper to the steel substrate deactivates the super glue. I think it actually just breaks down the bond, but you also get this similar metal expansion which can shear the super glue off as well. So here I just heat it up, and then I just pry off the 2 pieces of copper, and we are ready to mount the electrode onto our block that I was describing earlier with the 3R chuck. Alright, and then we load this 3R chuck into the receiving chuck of the Sodic Sinker EDM machine. And this is kind of an older machine. I think it's maybe 20 years old. And then here is the mold core that I pulled out of the molding machine, or out of the mold itself, that, you know, made that first green part where the back wall sank in. And here I'm loading it into the mag chuck, or well, actually a Kurt vise that's mag chuck down to the magnet chuck, which then sits on a ceramic mill table. So that brown surface is actually a high strength ceramic. And you can see the grounding wire, a supplemental grounding wire, because you need to ground your part. And then the positive voltage off of the copper electrode in that chuck there is what creates the high voltage sparks that eats away the aluminum. The copper basically stays intact. It's kind of like a much more resilient metal for spark erosion than the aluminum is. And here you actually use your tool itself to touch off and find the location of your part, as opposed to an edge finder or a 3-axis probe in a mill. But here you're actually move your electrode in until you create a short, like an electrical short, and that signals the machine that you're in the right spot. But here I'm discovering that I don't have enough travel in the way I oriented this mold core. As you can see, the travel limit was right there, and it wasn't quite far enough for my rib to fit. So I had to reconfigure the setup to rotate the mold core 90 degrees, because this, like most milling machines, this EDM machine has more of a travel in the x-axis than the y-axis, or the z-axis. So here I'm going to flip it around and remount the mold core, the aluminum mold core, and then reset up to EDM our ribs in. So now we got the mold core rotated so we have full travel, and I'll repeat the process of using the electrode and the EDM machine looking for an electrical short to reset up the location of our mold core and basically dial in our rib locations. After which I do a real simple program, which I didn't get much footage of, but you basically just answer a bunch of questions in the EDM machine to set your program for spark eroding away your thin rib slots that we're going to cut into this aluminum core. And it basically does like a hogging operation with a heavy spark to remove a lot of material, and it goes back and kind of side polishes. So the actual electrode will move left and right when it goes to depth to clean up the sidewalls of your part. So after everything is set up and you actually execute the program, the EDM machine will do a few things, and I think I'm making sure that the part is fully set in the vise. But what happens is a wall will rise up out of the machine, and then inside of that wall, the parts and the vise and everything will be submerged in a paraffin oil, which is a very thin oil, which is called the dielectric fluid. So here the program is started, and the machine will bring the electrode down to 1 millimeter above the zero. And here's the wall coming up, rising up out of the machine, which contains basically this tank of oil, which is now starting to fill up the tank that popped out of thin air. And you can see the oil rising up. So that's not water or dielectric or like DI water. That's actually really thin oil, almost like brake fluid, but not nearly as reactive as brake fluid is. And the idea is that you cover up the area where the spark erosion is going to occur, because and the oil actually will control the spark gap, or the basically the size of material that's removed. It also flushes away soot and all of that good stuff. You do want the oil to be high enough above your part so that it doesn't tend to ignite the oil or ignite the vapors that come off from the oil as the sparks are starting to eat away. And that hopping up and down motion is also designed to flush out the burned oil and the little balls of metal and slag, and flush in new liquid by basically pumping liquid in and out every time it undulates up and down. Here's a more of an up-close view of the beginnings of the cut, where the machine is kind of settling in and figuring out its voltages and current and spark time between flushing operations. So here I pause the machine and I'm going to lower the oil bath down and basically just measure to make sure I've got my initial witness of the rib in the right spot, so I can see just the very beginnings of the eroding away of the aluminum, and I confirm that the rib's in the right spot. So then the machine will resume. It'll bring its electrode back down into the oil and start to eat away again. I think I sped this up. But this is full speed, and you can see to the top left some impressions of small white sparks. That's electric sparks burning off the aluminum as it cuts away. And EDM machines are a long man's operation, so this whole operation probably took all day. So EDMs usually are not very fast, but it's kind of a set it and forget it, but keep an eye on it to make sure it doesn't catch on fire. You could probably also see that I cheated, and I basically just didn't have enough exposure on the copper electrode, so the mounting hole that I made isn't actually lined up with the bolt. So I wound up just pinching the electrode further down instead of remachining another one. The nice thing about EDM machines is that there's very little force or no force on your actual electrode itself, so you can get away with little tricks like I did there with basically just pinching it with a washer, the electrode copper that is. And since there's basically zero contact, but the spark is actually creating the mass removal, you can get away with some things like my little cheat there if you didn't notice. Alright, so we're approaching the end of this particular rib. This was a shorter rib, as I believe. And I think you'll see some side milling at the very end here, where basically the up and down plunging still occurs, but you'll see like sparks on the face of the copper instead of just the edge, which is right here. And since this is a retrofit, I could basically just put the mold core back into the mold here and try it out and see how the ribs acted, and to make sure that the part ejects. Okay, so in conclusion, if your part is warped, add ribs to the inside. You want to make the ribs about half to 2/3 as thick as the actual wall thickness of your part. That way you don't get sink marks or blush marks, but you can still see a little bit of evidence of sink marks on this part if you get the lighting just right. And yeah, with polypropylene, it's kind of hard to completely disguise or get rid of sink marks because its mold shrink factor is, I think, 20 thousandths of an inch per inch. So it's pretty high. And but ABS is a little more forgiving, and polycarbonate and things like that. Anyway, but here is our part with the ribs, and here is the mold core with the rib cuts. So thanks for watching Dragonfly Engineering. See you next week.